In this section, we're going to be talking about how to find the area between two curves. If f and g are continuous functions on the closed interval a to b, and if f of x is greater than or equal to g of x on that interval, then the area of the region bounded by y equals f of x, y equals g of x equals a, and x equals b is given by the formula a equals the definite integral from a to b of f of x minus g of x. And sometimes you'll hear me refer to it as the upper function minus the lower function. And I'll talk a little bit more about what I mean by that. But let's start off with an image. So here's my y and x axis, and here's a, here's b. So here are my two poorly drawn functions. I'll call this f of x, or my upper function, and this is g of x, or my lower function. So if I found the definite integral from a to b of just f of x, then that's going to give me this green region here, the area of that. And if I found just the integral of g of x, that's going to give me this region down here. And so if I wanted to find the area of the yellow region that's just in between these two curves, then I could subtract those values, so basically I'm doing a to b of f of x dx minus a to b of g of x dx, which is the same thing as this, because remember, you can split integrals into sums and differences, and that is representing area of the yellow region in the image that I just drew. Let's go ahead and use this in an example. Example 1 says find the area of the region bounded by y equals the square root of x plus 4, y equals x, x equals 0, and x equals 3. I'm going to draw a little picture to help me out. So y equals the square root of x plus 4 looks something like that. And then y equals x is a linear function that goes through the origin. So notice here, this is my upper function, and this is my lower function. That's important. And then x equals 0 is right here, and x equals 3 is somewhere like about there. So I'm going to highlight the region that I'm trying to calculate the area of, and that's going to be right there. So the area of the shaded region is going to be given by the integral from 0 to 3 of the upper function, which is the square root of x plus 4 minus the lower function. And you'll often want to put parentheses so that you end up doing the algebra correctly. So let's do some integration. That's going to end up being x to the 3 halves times 2/3 plus 4x minus x squared over 2, evaluated from x equals 0 to x equals 3. Now, what's nice about this problem is if you were to plug in x equals 0 into these terms, all of them have an x, so they would all become 0. So really, we only need to evaluate it at x equals 3. And then if we evaluated it at 0, it'd basically be minus 0. So 3 to the 3 halves power is the same thing as the square root of 3 times 3 times 3. And since there's a pair there, I could rewrite that as 3 root 3. And if we're multiplying that by 2/3, then that 3 and that 3 will cancel out. So that's going to end up simplifying to 2 root 3. So we'll get 2 root 3 plus 12 minus 9 halves And then 12 we could rewrite as 24 over 2. So that would become 2 root 3 plus 15 over 2. And that is our final answer.